Hi, students. Let's look at this question, which is on hypothesis testing. Let's see how I can do this proficiently. So, a beverage company produces thousands of cans of soda each day. The volume of a soda in a can follows a normal distribution, with a mean of 355 milliliters and the standard deviation of 1.2 milliliters. Okay, following the maintenance of the filling machine, there may have been a slight adjustment. So to determine if the machine still produced 355 milliliter of soda per can, 15 randomly chosen cans are chosen. The volume X ml of the 15 can soda is summarized as below. So this is the case here. Okay. Now, assuming that the variance of distribution is unaltered by the adjustment, test at the 6% level significance whether there's any change in mean volume of the soda. Okay. The thing is, if let's say you're a beverage manufacturer, you have to make sure that if you promise that each can of soda is 355 milliliters, it has to be exactly 355. Because if you give more than what is stated, you lose money because you're actually giving more. Then if you give less than what is stated, consumer will complain, then you will also lose money. So essentially, you have to have that accuracy where it has to be 355 ml, right? So that's the case that it has to be when it says any change. So this is a two-tailed test. Okay, so what I'm going to do is I'm going to write down everything down. So I'm going to define everything. So this case here, we know that H naught, right? H naught here, mu. The population mean is 355 milliliter. Then H1, we want to test alternative hypothesis as not equals to 355 ml. This standard deviation here was given to us. So this is a population standard deviation, 1.2 ml. Okay, then we have everything here. N is actually equals to 15. Then we need the sample mean, right? Mean mass. So this is where we test. So this guy, we don't need this because this is just, we don't need the unbiased estimate of population variance because we were already given the population standard deviation, which is the gold standard. Always use the gold standard is given. This is actually just a distractor. So we just divide by 15. Taking calculator. This will be 354.3 ml. Okay. What else we need? We need the level of significance, which is actually 6% level of significance. So right now, under H naught, so there are two methods here. You can either use a classical rejection method or just use p-value. In this case, to be easy, to keep it simple, I'm just going to use a p-value method, right? You don't need to use CLT because the population is already known to be normal. So what I'm going to do is I'm going to use from GC, just key out the p-value. Now, there are many ways to write your test statistics. Different school would subscribe to different way of writing. So it is perfectly fine to just whichever way, that there's no one sure way. Okay, so there are many ways. So I'm just writing in the sense that like the one which is the most acceptable. So what we're gonna do, usually what I would like to do is I like to use the standardized form because then you don't need to like, but obviously if you don't like to write in the standard normal curve, you can just use the actual X bar, right? So but anyway, this case here, to find the p-value, just go to stats, then you go calculate, then you go to test, then you go to z test, right? Now currently in your syllabus only z test is tested. So then you go to stats, the mu naught, what I'm going to key in is actually 355. Then your sigma will just be 1.2 ml. Then your X bar would be 354.3. Then whereas for the N, we have got 15 cans, right? 15 cans. So here, what we're going to do is a two-tailed test. Then I'm going to just calculate. Okay, calculate it out. So from here, the p-value is 0.23868, which is actually lesser than the 6%, which is level of significance. So then we just write down the concluding statement. So since p-value is less than level of significance, we reject H naught and conclude that at 6% level of significance, there's a change in the mean volume of soda in the can. Okay, so that's how we do this question proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.